Okay, so for this next screencast for week 14, the second one, I just wanted to talk through a little bit about our research and our presentation forthcoming. So we read a paper by a couple folks who were researching the effects of this TEAL project, which is various set of visualizations and simulations at MIT in the undergraduate physics class, specifically in electromagnetism. And they were looking at the effectiveness of that new visualization program and animations. And so what they concluded was that a couple things. One is that visualizations offer students nonverbal models for building understanding of normally abstract electromagnetic phenomena. And so they claim that their visualizations are better than visualizations have been put out in the past, partly because of the resolution and partly because of the way that they represent electric fields, for example. They do things like describe electric fields on their diagrams as totally space filling or filling the space around a charge. And so I'm going to demonstrate that a little bit. Call this up. I think you'll see this. Yeah. Okay. And so this is kind of what we did with our equipotentials, which was a wonderful way of, sort of looking at this and making an analogy to topography in terms of the potential. But so the way that the TEAL program works is it makes these diagrams that show electric fields that totally fill the space. And so this is kind of like, I guess, Faraday, suggesting that it is a continuous field in between charges, and it is actually the pressure on that field that will transfer force to the next part of the field, and so on. So it's almost like it's an ether, it's a material, the electric field. But it does suggest that it's continuous, and it seems like it would be. Whereas a lot of students might be misunderstanding exactly what is in between the field lines. Is that a real representation, or is it just a kind of a construct of, representing the field with a more simplistic type of diagram? So anyway, they feel here in the TEAL project that this is much more useful. Another reason why these authors suggested the TEAL project was more useful and offered students better opportunities for conceptual understanding is that students work collaboratively when they were engaging in these types of simulations. And the simulations come in two flavors, active and passive. The passive are more like where you just kind of watch an image, or you look at a still image, or you watch an animation. And then you go ahead and discuss it with your peers. You have, your teacher as a mentor to kind of to work through some ideas. You also have problem-solving tasks. So it's much more sort of a engaging, collaborative kind of effort rather than just, looking at the animation and not, involving other types of activities. Another thing that they stressed was that time-varying graphs were very useful. And a lot of these animations are active animations or active simulations, they're referred to, and those would be ones that allow physical parameters to be manipulated, and then watching what happens over time. And so getting a graph produced, similar to what Vernier produces with the Logger Pro, also similar with what FET does with their simulations. And so, the interactive types of visualizations seem to enable people to get a better feel for how things work. And they can do experiments that way as well. So, you don't have to necessarily set up a whole lab station, but you can do an experiment at home on your computer about, well, gee, what happens to that, electric field strength as the voltage changes or as the displacement between, plates change. And so the TEAL project does seem to have its benefits, but at the same time, I tell you, it was very difficult for me to open up many of these files. And so, for example, I had Java downloaded, or I did that myself. And then, even the tech integrators at the school weren't able to figure out how to get a lot of these to run. And so, for example, if we look at, what I was really interested in is going to these vector fields, since I'm kind of assigned with looking at simulations in potential. I really was interested in using this applet here, which allowed you to visualize equipotentials. And so if I try to open this, it will not allow me to do so. And so I'm not sure what the deal is, but it is not letting me do it. And if I accept the risks, try to run the application, I am getting a message that I'm still unable to launch it. So this is frustrating. I'd say so. Several of these simulations were not being able to be run by me just because I didn't have the software to run them. Some other visualizations that we sort of looked at here. So we looked at the TEAL, and then we also looked at lots of other visualizations. So I listed a bunch here. This one's very intriguing. It's fairly simple, but it is wonderful because it actually relates to these little mini simulations. These are passive in the sense that I'm not able to do anything with them, but I can watch and I can see the diagram, how charge density changes, so how the charge changes on the plates as they come together, and also how the displacement changes and how that affects the electric field strength. And so you can see that in the diagram, but it also allows you to directly link that, or it's also directly linked to the equation here. And so I can kind of get the mathematical model as well as the diagram, the visual model, to sort of be connected. And so I can kind of, keep that mental image in my mind of the visualization of the nonverbal model, and while I'm looking at the equation. So this is what I went to when we had the discussion about a question on one of the worksheets for Unit 2, where we were looking at comparing the potential difference between plates and field strength of the initial and final states. And so it seems that the electric field strength was the same for both in that problem. And, I sort of got a much clearer understanding when I went to this. Now, the TEAL visualizations, they seem to have annotation, but not very much. They claim to have them, and maybe it's just a function of the idea that I was not able to access a lot of them. And so anyway, I'm going to look into that more, and hopefully I'll be able to really get an appreciation for what the TEAL project is all about. And so that is all I'm going to say about that. And there's several other simulations that I listed for this unit, but I think I'm going to